Hi, I'm Telly Mahoney, and welcome to The Good Room, where we have interdisciplinary conversations about what makes a room good. And today we're talking about a good clean room with Scott Calkins, who is our very first mechanical engineer on The Good Room and has worked on a range of clean rooms in the advanced manufacturing industry, and Verrick Walker, who is the science and technology director at Page. So, today we're chatting about clean rooms from an advanced manufacturing and a science and technology perspective to learn how these industries are paving the way towards the future of a good clean room. So, for those of you who don't know, a clean room is a highly controlled room that has to meet very stringent cleanliness codes. That's because the work that's happening here is highly, highly sensitive. The design of clean rooms are heavily dictated by the work that's happening within them. So, Verrick, do you think you could start us off with describing what work is actually happening in that clean room from a science and technology perspective?
On the life sciences side, which is typically where you see the clean room application, more on the pharmaceutical, either R&D, so research and development side, or actual production and manufacturing, where there's specific exploration on developing new drugs, new therapies. And then food industry would be another one of those, kind of in the same category, where they're actually doing food science or production. And the one other category I was going to mention on the energy side, so I know science and technology, but again, they're kind of collaborative and cross-sector. On the energy side, we do a lot of oil and gas research, and believe it or not, there are applications for so-called clean room space there, where they're looking at extracting oil from subsurface, and there are microorganisms that are part of that extraction or part of the potential contaminants. And so having clean spaces that take out all those potential contaminants from the environment and be able to conduct the research in that particular context.
Yeah, I think Verrick just really hit it on the head there. Really it's in the advanced manufacturing, and specifically the microelectronics is the word micro, is these things are so small, these devices that are being created within the clean room, that any kind of contaminant, it's a dust particle, anything in the air that could land on these microelectronics or these tiny devices could impact the yield of manufacturing all these and the performance of them. So the cleanliness of the air within the space is very important.
In the first category, you're protecting organic or life-related things that may or may not go into a human body or an animal body. Advanced manufacturing side, more on the inorganic side, or these are materials and things that are going to go into equipment. So non-living things, if that distinction makes sense.
Could you explain a little bit how you might achieve those levels of cleanliness?
First, the environment needs to be determined and classify what needs to be achieved relating to the International Organization for Standards, or we call them ISO, or maximum allowable particles within the space. The most clean classification is ISO 1, which only allows less than 10.1 micron particles within a cubic meter of space. So to put that into perspective, the average diameter of a human hair is 70 microns. So it's something that you can't see with your naked eye. It is very small particles that they're trying to remove from the air. So to make sure that they're getting this done, there's a couple different measures that are typically taken. So one is the filtration system itself, using high efficiency particle air filters or HEPA filters and ULPA filters. And those are the most commonly used to remove particles from the air. In the clean room, you want to maintain positive air pressure in relation to spaces nearby that might not have these same cleanliness requirements. And a lot of times in the advanced manufacturing space, a lot of hazardous airs or chemicals are used within the space. So exhaust or air taken out of the space to protect the humans in the space, as well as remove those contaminants to be treated before sending back out to the environment, causes a negative pressure in the space. So bringing in additional outside air and cooling it and treating it and maintaining the cleanliness is another step. And also monitoring those airflow within the space to make sure that the air is always changing. You're always pushing clean air through so that air contaminants don't land on surfaces or accumulate in other spaces.
This place, I imagine, uses a lot of energy with all these HVAC systems and the different processes happening. Is the idea of sustainability consideration?
Yeah, I'll simply add to that as a for instance, right, a very specific example. around this idea in the pharma industry of, and it happens in the animal research space too, but so-called disposable technologies or single-use technologies, where there's this notion that from a regulatory and cleanliness and accountability standpoint, so these competing goals, if I use these things, I only use it once, I don't have to worry about how well I clean it, whether or not it's been inspected or not, because it's one and done, right? I use it. And so I protect the process in that regard, line the vessels with bags or what have you, or these special kind of plasticized containers where the batches are created, et cetera. And then I throw it away. Great in terms of contamination control. Probably not so great in terms of sustainability, because I'm creating this waste stream and I'm doing it a lot too in terms of volumes that I'm producing. So this idea of how do we balance what's required from a protecting a health and wellness standpoint and the safety and all the things, the reasons we have clean rooms and put all these controls in place, versus this idea that is there a better and more sustainable way to do it? So yes, you have the big vessels. Yes, they take up lots of space. Yes, you have all these protocols around the cleanliness, tried and true. But in theory, you're generating less waste in that process. And so you can make arguments in either case of what's the priority. And it usually boils down to what's the priority for the particular business owner. And the great things about businesses, good and bad thing about businesses is they're private, right? So businesses only last if businesses make money and are able to sustain whatever that business activity is, to be able to create more jobs, to be able to provide more products and whatever the case may be. So they're driven by a different model than kind of what's great for the planet. So there's always this conversation of how much can we do what's great for the planet beyond my immediate businesses and price, but recognizing at the end of the day, I have to be profitable in order to have a business that will be here tomorrow that has kind of these benefits that are also contributing to society, but from a different perspective. So that's one in the industry, continues to be a challenge. But the good news is, as this becomes more and more popular and more of a discussion, it gets into these novel technologies where they have biodegradable plastic systems, as a for instance, and I use plastic in quote, organically generated. So these alternatives to kind of the legacy carbon-based or petrochemical-based plastics as a way to think about, well, how can we get the best of both worlds, kind of support some of these competing goals and objectives around kind of efficiency, cost, protecting the integrity and contamination that these clean rooms are kind of built around, but also recognizing that there's an impact to the environment associated with it.
Touching on the microelectronics industry, it's very heavy on gas and chemical usage to create these products, which ultimately, the air, the water coming in, the wastewater going out is tied back to our environment and being a sustainable planet. So while the need for technology is rising, really what the industry is looking at for these clean rooms or the advanced manufacturing spaces, how do we reduce our footprint? How do we achieve the same goals, whether that's reducing air pollutants or wastewater pollutants? How do we reduce those without increasing energy so much? Because we have a lot of great technology now to reduce air emissions or even wastewater emissions, but they do require a lot of energy to sustain those.
If you had a firm that came to you and said, we're looking to reduce our environmental impacts by like 50% or something like that, what type of things might you do to help them meet that?
Well, that is a pretty heavy topic there, but it's the direction that we need to go as an industry, certainly. Advancement in technologies to become more efficient is key in making sure that the most advanced technology is used, or the most energy efficient systems to date are used for their design, and then helping them understand from a high level what they're trying to achieve from the product and what goes into it, to understand what's required from a utility perspective, whether that's your water and the wastewater generated, as well as the electricity, which goes into all of that. How do we come full circle to determine the best need to reduce water and reuse water while minimizing energy consumption into those spaces?
One other thing I might tack on, and again, a very specific instance, but part of the conversations around that we often get into is, why are you doing what you're doing the way you're doing it? We talk a lot about clean rooms a big box, a big space, but especially on the life sciences manufacturing scale, especially at the R&D level. One of the things we often ask when the client comes in, very specific notion, I need ISO 4 or I need ISO 3 space, I need a room that does that. The first question is, well, what are you doing? And are you sure you need a room? Or can you just do that in a containment hood, so-called containment hood device, a biosafety cabinet? Can that contain? So if the operation is in a 3x3 space or a 2x3, and that's the critical activity, do you need a 50x20 space to be at an ISO 3 or an ISO 4 in order to manage whatever that activity is? And so being able to ask and answer those types of questions, nope. And I'm thinking of a particular instance project we're working on now. That was exactly the conversation. The answer was, well, now that you mention it, no, I only need to protect this little space right here. Huge impact on the design. Now we're not designing a box, what did I say, 50x20, 1,000 square feet plus the volume or whatever. Now we're taking it from that to something that is more in the range of a 4x2.5 footprint. You can see how that has a much different implication. I'm able to recirculate that air to the room. I'm not having to create a huge HVAC system to support a much larger space. So the ability to ask and answer those kinds of questions, understanding what those processes are and systems are, has a tremendous potential, not only to reduce the kind of design of the systems, which has cost benefits, kind of tangential benefits, because I'm not building and installing and constructing these much larger systems. So it has those benefits to the client, but also just realizing that I'm also creating less demand, less resource utilization, less waste, and all those things that are part and parcel to this notion of sustainability and reducing energy, reducing impact on the environment.
You touched on that idea of the little box inside of a big box, so a room that needs to be really contained and sometimes not have light in it, and then the bigger box being the building that people also have the office work. And that kind of ties into the question of aesthetic. How might you use the other spaces of the facility to be able to pull in those aesthetic moments that are less function based?
Yeah, no, that's a great question. And it's always the challenge we have, especially when you talk about designing quotes and the appeal or not of these projects, is, well, you're just designing big boxes with all this mechanical and electrical and process equipment tagged onto it. And if I want to design Walmarts or Sam's Clubs or whatever, then I'd go do that. That it's not appealing. And I think there's some truth to that, but there's a whole lot that's missing from that. Again, one of the things that these are human beings, they're robots and technologies being leveraged in a lot of what's being done, but they're still human beings that are kind of involved. And so creating spaces that people want to go, especially recognizing that what they're doing inside that box, that clean room and that controlled environment with the bunny suits on, which aren't always comfortable. They may get warm over time, recognize there are bodily functions that need to happen, and you're having to regulate across all that. So while you may enjoy your job, there's a recognition that it's not always ideal and not always the best and always comfortable. So all those spaces, those so-called amenity spaces, the break spaces, the office environment, the workplace beyond becomes really critical to the success of these facilities, as much as the billions of dollars that are represented in the tools and products and things that are being manufactured, again, the so-called clean room. So things like collaboration space and rooms where folks can engage outside of those work environments becomes critically important. Just this idea of being able to bump into each other and think about, hey, I was thinking about this while I was in the room, and I think I've come up with a better way to do this process. The ability to sit down and collaborate and talk about that offline or outside of the context of immediate work becomes truly important. And so understanding that means we're able to engage our interiors team and our workplace strategist team and all those other people who are normally not thought of in this context. Usually, it's just the engineers, and then guys who like to hang out with engineers, architects who like to hang out with engineers, and that's all it is. But no, there's this idea of branding, which is very important to lots of our clients. In fact, the project that Scott and I worked on together, they rebranded, and the process of us delivering this project, and they even talked with us in another conversation about that. So even not only execution of the project, but even in terms of thinking about ourselves as an integrated firm, the ability to have those other capabilities and expertise and bring them to the table becomes important. Creating spaces that are inviting, that allow for respite and decompression and all those other buzzwords becomes particularly important, especially in demanding environments like this. And one other comment I'll make related to this is this idea that understanding where you are and leveraging the best of where you are and making the most of that, not only from a site standpoint, but whatever that may be. Thinking of two particular projects, one on the electronics production side, but also one on the life sciences side. This one client, again, in a very nice part of the Western United States, the building itself was not ideal in terms of what was happening inside the space, but recognizing there were opportunities adjacent to and outside on the site, and creating protected spaces that allowed them to go out and engage with that exterior environment meant all the difference in the world. It was one of these conversations I remember having with one of the team members there. And it's like, this place is 50 some odd years old. It's probably not the most contemporary in terms of state-of-the-art new facility. Why are you here? We walked over to the break function area. We walked outside to the meeting environment, sitting out in those spaces, and then the light bulb went off. It's like, I get it. And it's these kind of moments and our ability to design in these kind of moments that may have nothing to do with that chip that's being produced, or may have nothing to do with that medical device that's being produced, but it's connected to the people who are working in that environment and their ability to really appreciate those moments outside. That is the fun part, the other fun part of, not only from the technical, but the other fun part of a truly holistic approach to what might seem like a very simple technical and really not that impressive aesthetically piece of space.
Conversely, to touch on the fact, not just inside the space, but from a space overall, usually these are very large properties that will house some very large buildings on them. And when we talk about the complexity of the systems inside, usually goes along with requiring additional buildings or systems that need to be housed outdoors. Typically, these products or these projects require a lot of manpower to build and keep running after they have been built. So these are near communities. So looking at this from a design overall, from the community standpoint, making sure this is aesthetically pleasing to the community. When you have these large mechanical, electrical systems, it really goes into the design and collaborating together on how can we bring the space together, hide these systems or hide these not so appealing or unattractive systems to the public and even to the employees coming into the buildings. How do we hide those to make it just, an outstanding building to be at?
Yeah, kind of that idea of it being beautiful from the outside, looking in, a little bit of the inside looking out too. Well, thank you, Scott Verrick, for joining me today on this episode of The Good Room. And thank you to everybody who's listening.